Hello my dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. I hope all of you are doing good. So as you know, we are doing a master stroke for PU1. Today's chapter will be discussed on binomial theorem. So few students might feel that the chapter is a little lengthy, a little tricky, but actually bacha is very easy because we have only one formula to learn right now, and based upon that one concept, one formula, every question can be related and solved. Okay, so doesn't that make our life easier? Of course, you'll have in some questions combination of your permutation and combinations will be there, not permutations, mostly combinations will be there, so we'll see those as well, right? So I've taken some examples at the end. Basically, I've taken some problems at the end which will help us bridge the gap between the concepts and the problem. Okay, so let's start with the session right away. So we have first thing, please check binomial theorem of positive integral indices. Okay, so basically when the indices is 0, 1, 2 like that, please check here. When indices is 0, I get this value as 1. When I have 1, I get this as x plus a, and this is, you already know, x plus a the whole square, the formula we have learned from our grade 8 I think. Okay, then x plus a the whole cube, we have x plus a the power 4, and likewise we have the terms. So x power 4 like this, please check. So what happens basically is, so some special cases are there for an index of power 0, 1, 2, 3, 4. Okay, now if you generalize this, when this power becomes equals to n, then how do we deduce the value, sir? Then how we deduce the value, sir? We have this result, please check, very important. A plus b power n is given by, please check here, nc0, a power n minus 0, b0, nc1, this 1 will come here, 1 will come here, so here you have a power n minus 1. Basically, if you see the trend, power of a's keeps decreasing from n to n minus 1 to n minus 2, so on till n minus 1, and lastly it becomes equals to n minus n, which is nothing but 0. So the power of a, the first term in the expansion, will be of course going to be decreasing. Okay, so next bacha will have one, what, please check here, we'll have second term will be increasing from 0 to n. Over here what is the power? 0. Here what is the power? 1. Here what is the power? 2, so on till n. And if you see the coefficients, we have nc0, nc1, nc2, all the way to ncn, all the way to ncn. Okay, so that makes sense, sir. Now we'll please check. So these values nc, so this is the right final answer they've written, same thing. Okay, because over here no b power 0 is there, no, so we don't write b, and over here a power 0 is there, no, that's why we don't write a. Got my point? Okay, so the symbol ncr represents what, bacha? N factorial upon r factorial into n minus r factorial. You know that already from the concept of permutation and combination. Okay, this is the combination definition. And how we write this? N factorial means n times of n minus 1 times of n minus 2 all the way to n minus r. Why this, bacha? Please check. I can write this in with this way, no? N minus 1, sorry, n times of n minus 1 times of n minus 2 times of n minus 3 dot 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 till n minus r minus 1. Next comes n minus r, and after that I'll continue like this. I'll write here factorial, okay, divided by what I have, bacha? Please check. I have here same thing, r factorial, then again I have what? Please check. I have here n minus r factorial, right? I can cancel this and this part, no? Now it's the same thing written over here, n into n minus 1 all the way to n minus r minus 1 numerator. And what is this part, sir? This is nothing but r factorial. How much is this? R factorial. Okay, simplification of this order. Okay, so why we are using this? Because sometimes it will be easier to get directly from here. We don't have to use a straightforward formula all the time. Okay, but you can use either of them. Moving on. Now, few important notes. If you understand this, no, it'll be easier to remember the big expansion. Is it big? Is it difficult? No, not at all. But can they remember it easily? Is there a way? Yes, there is. Please check. The expansion of a plus b power n when n belongs to natural number can also be written as a plus b power n. In this way, please check. Summation of ncr's where a power n minus r is there, b power r is there, starting from 0 to n. If you don't believe me, just write from here. First term, what is the, bacha? R equal to 0. So nc0, a power n minus nothing, right? 0. So n only. B power what, sir? B power 0. What is that going to be? 1. Okay. Next term, r will become 0 to n, right? So r will be 0. Next term will be r equal to 1. So we'll write here nc1, a power n minus r is there, na? So r will be 1 and b power 1. Same way we'll keep going on like this. We'll have last term as ncn. Please check, the last term is n over here, bacha. N, okay? So ncn we have, and will become equals to, please check, nc sorry, I've already written that, no, excuse me, I've already written that part. Yes, NCR is already taken as NCN, because taking R value as n, no, we'll have this as a power n minus n and b power n. Isn't the same as the expansion we just saw? Please check, a power n minus n and b power n. So basically I can write this entire expansion in this term, this expansion. What is that? Please check here. Summation r starts from 0 to n, NCR a power n minus r and b power r. Please check. I can just write this instead of writing the entire expansion. Sometimes we use that, okay, in the questions we have to relate from here, so that's why we have to know this, very important, okay. So the total number of terms in the expansion will always be, bacha, if the power is n, no, whenever you have binomial over here, no, when the power is n, you write the expansion will be, please check, one more. So basically it becomes a what? It will become n plus 1. One more the exponent of value, okay. So our exponent is n over here, so the result will be n plus 1, okay. Very important result. In each term, the sum of indices of a and b is always n. Yes or no? Please check. Sum of the terms. Bacha, add this indices, n minus 0 plus 0 is always n. N minus 1 plus 1. N minus 1 plus 1. Cancel sir, again 1. Over here, bacha, n minus 2 plus 2. Cancel here, again n. So every time the sum of the indices will always be equal to n. What next, sir? In successive terms, the index of A decreases by 1. I just explained you this part. And index of B will increase by the value 1. Explain this part to you, right, already. So the coefficient of NC0, the coefficients we have NC0, NC1, NC2 in the expansion of A plus B are called the binomial coefficients, okay, and can also be written as this form. C0, it means NC0, C1 it means NC1, C2 means NC2, and Cn means NCn, of course, right? All of you agree? Let's move on now. So that's why I said these things will help you revise that or memorize the formula easily. That's why these notes I've taken over here. Moving on now. Some special cases. When I have, basically when I can write this b as minus b, write this a plus b as 1 plus x or 1 plus x, that's what all we have, okay? Excuse me, I think something happened. So now I hope it's okay. So we have a, whenever I can replace this b by minus b, okay, we get, please check what we get, bacha. Everywhere wherever is b, no, you'll replace that by minus b. So odd power will make it negative. Please check, odd power will make it negative. B power 1 is there, no, it makes it negative, and even power will be bacha, positive. You'll have even power as positive. Please check here, power of b is even, no, so positive. Why only b's are not a, bacha? Because b is negative, now that's why. Whenever I'm taking b as minus b, right, I'm taking b as minus b over here. For that reason, whenever that happens, I have odd powers as negative, please check, and even powers always positive because of this reason. Minus 1 power n, bacha. Got it? Moving on, the signs plus and minus appears in alternatively, okay, means we have alternately plus and minus because of the even and odd powers in the binomial expansion of a plus b power n, basically a minus b over here. A minus b power n, okay. Taking a equals to 1 and b equal to x, I can write this whole 1 plus x power n. No biggie. Same concept, bacha, same concept. It'll become same thing, no, NC0. Simply replace a by 1 and b by x in the expansion. A by 1 and b by x in the expansion. Moving on. Taking a as 1 and b as x in the expansion, we have this, of course, acha, b as minus x over here, excuse me, b as minus x over here. What I get, bacha? I get this value as, again I said, x is the negative, no, so odd powers of x will be negative term. Please check odd power is, sir, 1, so negative term. Even power is positive. Same way, if the power n is odd, what will happen? It will become negative, bacha, okay. Sum of binomial coefficient is given like this, c0, c1, c2, cn equals to 2 power n, okay. When x is 1, you can take this and get the result. Put this x equal to 1 in the expansion of 2 and get the result like this, c0, c1, c2 plus cn equals to 2 power n, okay. Again same, we have some more concepts. We have c0 plus c2 so plus c4 and c1 plus c2 plus c5, like odd powers, sorry, odd terms we are taking and even terms, we get the result to be 2 power n minus 1, okay. What else we have? C0 plus C1 plus C2, same thing written over here, bacha, same thing like this. Please check. Okay. What next now? Number of terms in the expansion, very important. If I have, like, let's say 1, 2, 3 and so on till r terms, the formula is n plus r minus 1 c r minus 1. N plus r minus 1 c r minus 1. That's your formula for number of terms when you have r terms in the expansion. Okay, chaliye, now we have some questions to solve. Let's solve them quickly. What is that? So number of terms in 2x minus 7 by power 7. Number of terms in 2x minus 7 by power 7. How do you solve it, sir? Of course, bacha, please check here. Exponent is n equals to 7. What did I say? Add 1 to that. Add 1 to that. So your number of terms will become n plus 1, giving a value to be 7 plus 1, which is how much? 8. So option number D. Option number D is the correct answer. Okay, excuse me, forgive me for that. Okay, option number D is the correct answer. Okay, all right, moving on now. Question number 2. If 1 plus ax power n equals to 1 plus 8x plus 24x square, okay, the expansion is given, then a plus n is equal to how much? Then a plus n is equal to how much? How do you solve this part? Please check. So I can write from here, no expansion for this. 1 plus ax power n, bacha, will be nothing but, have a look, it will become nc0. Okay, you'll have 1 over here and ax power 0 will be there, of course. Next will be, sir, nc1. Okay, 1 power, what will there, bacha? N minus 1 will remain 1 only, no, doesn't matter. And you'll have ax as it is. Next, bacha, what you'll have? nc2 ax power 2. Ax power 2. Agreed? Okay. Now, same way I can keep continuing like this. But do I need more than that? No, sir, because we have x square only, no? That's why I'm taking only the power of 2. That's more than enough. Let's simplify this. How much, sir? So it's going to be nc0. I don't read that. I don't need this, bacha. I don't need this part. I can simply write this as c0, okay? I don't need this, so. And I simply this as c0, okay? For this I'll write, it'll be n ax, okay? And for this I'll have n times of n minus 1 by 2 ax the whole square. If you're asking me how, please write this. nc2 equals to, bacha, please check, n factorial upon 2 factorial times of n minus 2 factorial, okay? Right? So from here what you're going to get? Please check. You're going to get n times of n minus 1 times of n minus 2, no? N times of n minus 1 times of n minus 2 factorial, right? Which will cancel this in this part. And you'll end up with, please check, n times of n minus 1 by 2. Same thing I've written over here. Right? Okay. Let me just remove this. So that's the working to explain you this part. Now compare the like terms. 8x to nax and this to this part. Okay. So we'll do the first comparison. 8x to nax. From here I get x and x cancels. So I'm getting na equals to 8. Have a look. Okay. What I have next, sir? 24 x square equals to, from here I am getting n times of n minus 1 upon 2, and I have ax the whole square, so it will become a square x square. Check here, this and this cancelled, okay, and I can write this a in terms of n, no, from here it will become, a becomes equals to 8 by n, right? Exactly, a equals to 8 by n. We can put it back over here in this value. I get 24 equals to n times of n minus 1 by 2, 8 by n, right? So I get 8 by n the whole square, 8 by n the whole square. Let's proceed this simplification. We can multiply 2 on this side, cross multiplication will get 48 equals to n times of n minus 1. We have 64 by 8 for 64 by n square. This and this is cancelled. I can cross multiply this. Okay, before I do that, I'll move 64 on this side. It will become 48 by 64 equals to n minus 1 upon n. So I can write here, please check, 48 by 64, right? Yeah. So I write here 8 6 24. I can write, no, 12 4s are, and no, not 12, 16 I can write. I can write 16 actually, better. 16 3s are and 16 4s are. Okay, so what I'm getting, bacha, 3 by 4 equals to n minus 1 upon n, cross multiply, I get 3n equals to 4n minus 4. Move this 4 on this side and this 3 on this side, 3n on this side, I get 4 equals to 4n minus 3n, giving the value of n as 4. Value of n as 4. So please check here, if value of n is 4, it means value of a will be 8 by 4. How much is that? 2. So value of a is 2, value of n is 4. What are they asking us? A plus n, right? How much is that? Option C. Option C. Please check. Value of n is 4, value of a is 2. What are they asking us? A plus n, how much that will be? A plus n will be 4 plus 2, so 6. Have a look. Done? Good question. It's a very good question. Moving on now. The number of terms in the expansion of x plus y plus z power n. Okay. Please check from here. I have x plus y plus z power n is there, na? So I can see here r is nothing but 3. R is nothing but 3. So have a look. I have the formula as n plus r minus 1 c. I have over here r minus 1 only, right? This is the formula for number of terms. Number of terms, right? I just explained you this part. Okay. So r value is 3 means I can write this as n plus 2 by 2, because if r is 3 means r minus 1 is 2, so n plus 2 upon n plus 2 c2, I get here n plus 2 factorial upon 2 factorial, okay, and we have n plus 2 minus 2 factorial, correct now? This factorial upon this 2 factorial times of n plus 2 minus 2 factorial. We get 2 and 2 cancelled. It will become, bacha, n plus 2 times of n plus 1, okay, times of n factorial. Correct now? N plus 2 will become n plus 2 times of n plus 1 times of n factorial. And what is in the denominator? We have 2 factorial. How much is that? Simply 2. 2 into 1, so simply 2. What is this? What? N factorial. This part is n factorial. Can you cancel this? Of course, sir. What I'm getting, please check. I'm getting this value as n plus 2 times of n plus 1 upon 2 upon 2. So which is that? Option A is correct. Option A is correct. Done? Have a look. Alright. Let's move on now to question number 4, which will be the last question from this topic. So let's complete this and complete our chapter as well. The greatest integer m such that 5 power m divides. So basically we're looking for the value of m. So basically which multiple of 5, that's what they're asking is, which multiple of 5 will be able to divide this thing, will be a factor of this. What is the question? Which multiple of 5 will be a factor of this expression? That's the question, simplified version. Let's have a look. What is there? We have 7 power 2n plus 2 power 3n minus 3 and times of 3 power n minus 1. Excuse me. I can simplify this. It will become, bacha, 7 square will be 49 power n plus, I can write this 2 power 3 n minus 1 times of 3 n minus 1. So I have this as, please check, 50 minus 1 power n plus 2 power 3 is how much, bacha? 8 power n minus 1. 2 power 3 will be 8, okay, and into 3 power n minus 1. I have same power, no? I can multiply the bases. 8 into 3 is given in the product, right? Please check. I have n over here. Over here what I'm getting? 24 power n minus 1. Now please pay attention to this. So what I am getting over here is 50 minus 1 power n. I'm getting over here plus 24. So 25 minus 1 power n minus 1. N minus 1. Now please pay attention over here. So please check over here. What I'm getting is, so if you expand this part, no, I cannot do that because n is going to be a, so there's no need of expansion. Understand this. Whenever it is not a fixed number of n and n, only the variable is present. It means you have to use more logic than the calculation. There's no need of calculation, but only logic is required. So please check the logic now. So n is there, na? So I can start from 50 power 1 to 50 power n. First term, 50 power 1 to 50 power n. Yes or no? sorry, 0 will be there, of course, it will be 0 only, don't worry. So 50 power 1, 2, 50 power n will be there. Okay, great. So basically it will give me multiples of 50, multiples of 50, correct na? Same way this will also give me multiples of 25. What about this part, bacha? It will give me minus 1 power n, and this will give me minus 1 power n minus 1, whatever is the term. I don't want to say second term, third term like that. Generally this will give me this. Basic idea is, if let's say n is an odd number, so I'll have this as negative and this will become positive. Yes or no? N is odd number. Think about it. Let's say n is 7. What is going to be? Minus 1 power 7 is negative. What about this? It will become n power. So minus 1 power 6, because n minus 1 is there. So basically if n is odd, n minus 1 is even, and vice versa. If n is, let's say, even, what will happen to this part, bacha? It will become odd. So basic idea is, these two when you add, no, it will become equal to 0. So you'll have only terms like multiples of 50 and multiples of 25. Can you divide this by multiples of 50? You cannot do that all the time. For example, if I take, bacha, 75, can you divide this by multiple of 50? You cannot divide by multiple of 50. It means it has to divide by multiple of 25 only. Multiple of 25 will cancel both. Okay, so basic idea is, the minimum value that you can take, sorry, maximum value that you can take, not minimum. Minimum will be 1 also, right? And if I want to take this, I can take 5 power 0 also, right? It will become 1. 5 power 0 if I take, it will become 1 now. So m value I can take it as 0. I'm not looking for minimum value, I'm looking for maximum value, greatest value. So that can go up to what, bacha? 25 only, no? 25 will cancel any multiple of 25 and any multiple of 50 also. Will you take 25, will you take 50, 100, anything you take, it will cancel by 25. Same way, you take 25, 50, 75 like that, it will be cancelled by 25 again. It means 25 is the number which will cancel both the terms. It means my answer is nothing but 25. It means what is going, I can write this as 5 power 2. Compare this with 5 power m. I get m equal to 2. I get m equal to 2. Answer is option number A. Please check. As I said, less calculation, more logic. Less calculation, more logic. I hope you had fun. Okay, so we have completed our chapter Binomial Theorem. This is it. Have a look. Okay, let's move on. Let's begin. Okay, so what we have first is, please check. Over here is fundamental principle of counting. Again, for the cases of addition principle and for the case of multiplication principle. Okay, so in case of whenever you have this OR case, no, E1 or E2, what you do is simply take the number of event, basically for the event E1, number of ways you can write for event E1, and same goes with event E2 as well. Okay, so let's see. So suppose that there are n1 ways for the event E1 to occur, and same goes for the event E2. There are n2 ways. Then if you are writing the number of ways for E1 or E2, you write this as n1 plus n2. Whereas in the case of multiplication principle, we have to multiply them together as n1 times E2, and n1 times n2 for the events E1 and E2. Okay, because we are looking for both events to occur at the same time. That's why we are taking this multiplication over here. Means we cannot take only one event here. It's not optional. We have to take both together. That's why the multiplication is there in the case of fundamental principle of counting. Please check now. Next is, so of course, chapter name itself is permutation and combination. So first thing is going to be permutation. Okay, so before starting the session though, on the permutation part, I would like to tell you the comparison between the two. So sir, why right now? Because it makes our life easier. Because look, in case of permutation, we have to worry about arrangements also. Means how it is arranged. Okay, means order is very, very important in the case of permutations, but in the case of combination, just selection is important. No, not a problem with the case of how you are selecting it, which goes first. That is not important in the case of combination, but in the case of permutation, even the arrangement order is very, very important. That's the difference. Okay, let's have a look. So what we have, arrangements of a number of things taking some or all of them at a time is called as permutation. Okay, now of course, to help let's solve a lot of questions, we use what we use factorial notations. Reason being because they're so big numbers. Okay, so it's difficult to represent the multiplication 7 into 8 into 9 like that in a big in a simplified manner. So what you do, that is you use the factorial notation, right? For example, for a number x, okay, writing as basically x into x minus 1, x into x minus 1 into x minus 2 goes on till simply 1 can be written simply as x factorial, simply x factorial, okay? So written over here 1 into 2 into 3 into all the way till n is basically going to be your n factorial. You can write this as this as well or this as well. Two way of writing it. We usually use this method for a symbol for writing the factorial. You can choose either of them, both of them are correct, okay? Now please check, one more thing is very important here, 0 factorial is always 1 bacha. There's always 1, sir. There's proof for it, of course, but we don't need it right now. Just remember 0 factorial is equals to 1. Okay, so we are trying to learn every concept very in a very quick amount of time, because we have some time constraint right now, and again PU1 chapters are having less weightage. Still 1 marks can come from here. That's why I'm taking this even into consideration. Okay, so let's solve this question as well. So again, I've taken some questions in the session. So total of 5 questions I've taken. We'll solve all of them. So let's begin. Okay, next is bacha bijection principle. Let A and B are two finite countable sets such that there is a bijection. Okay, so this is useful when actually we are looking for whenever they say bijection is present, no, then just by looking at the number of elements in one set, I can say it will be the same in the case of second set. Okay, for example, check here, n of A will be equal to n of B if it is having a bijection. If it is having a bijection, okay, that's the relation. Number of elements will remain same in the case. Okay, so please understand this. Moving on now, we have permutations when all objects are distinct. Okay, what's the first one? This is the formula, bacha, npr equals to n factorial upon n minus r factorial. Your entire chapter is based upon this formula only. Okay, yes, there can be something more as well, but basically everything comes from here only in the case of permutations. Again, there's a different formula in the case of combinations, but permutation is going to be revolving around, all the questions will revolve around this formula only. So very, 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 very important. Okay, chaliye. So total number of permutations of n distinct object taking r at a time, taking r at a time. Please check here, this r bacha means out of total n I'm taking r at a time. Looking for the permutation will have n factorial upon n minus r factorial. Okay, the number of permutations of n objects taken r at a time is total number of arrangements of n objects in a group of r, in a group of r. So let's say I'm taking 2 at a time now, so 2 2 2 like that in a group of r. That's what it means bacha, where the order of the arrangement is very important. I said no, order is not important in the case of combination. Order is not relevant in the case of combination. Only this selection is important, but in this case you have to think of the order as well. Okay, which comes first? Let's say I have a case where A and P comes over here. Okay, I'm trying to fix A and P at the beginning, at the end. Okay, then I can take this ulta also. So I'll have two cases like this. Okay, so we've done a lot of questions like this, right, in our boards. So AP and PA both will be two permutations. Okay, but in the case of your combinations, we don't have to go like that. Please check. Okay, so let's just a simple example, not much we're going to discuss in this part. Chaliye. So without repetition, again we are talking about the permutation without repetition. So arrangement of n objects taken r at a time, same principle. Remember the formula was there, out of total n arrangements, okay, or n objects we are having, we are picking r at a time. Okay, and the formula was npr, okay, given by n factorial upon n minus r factorial. Same we are doing over here as well, but without any repetition. Okay, so taking r at a time in every arrangement is same as filling r places with n things. Think about it. For the first place, how many places possible I can take n, right, because total n are there objects. For the first place I can take bacha n. For second place, how much I can take? 1 is already gone, it will become n minus 1. For third place, I'll have 2 less because 2 is being utilized over here, right or not? 2 is being utilized over here. Think about it. Think about it. For example, let's say I have 3 digits spaces to fill. Okay, I have to use what bacha? I have to make a 3-digit number using your digits from 0 to, of course, 9, na? 0 1 2 3 4 6 5 6 7 8 9 till 9. So how many ways you can fill the first one? Of course bacha, only 9 ways, because you can't fill the 0. If you put 0, it will become and not a 3-digit number anymore, it will become 2-digit number. So you can't take 0 over here. That's why we have only 9 such outcomes. Now if it is without repetition, okay, means what is this going to be? Again 9. If it was with repetition, what I can do bacha? Over here it will become 10. Think about it. Means I can take, let's say I have taken the number 7 over here. Will the 7 come over here or not? Right, in this case I cannot take because it's without repetition, but with repetition it will become, I can take 7 again over here, so it will become 10 instead of 9. Okay, this 9 doesn't mean that number 9. Okay, it means 9 digits are there. I can take any other digit. okay. 0, 2, anything that is already taken, just remove that part, okay. What about this one, sir? Again you'll have only 8, okay, because of course you cannot take the other 2 that you already taken over here. So 9, 9, 8. So 9 into 9 into 8 will be your arrangement. Remember this? Same way, this is the case what I'm doing over here. First one, let's say I have n possibilities. Second one, I have n minus 1 possibilities, and like that it keeps going on till n minus r plus 1 possibilities. Please check, okay. So let me just erase this. Not an example, just want to explain you why they are taking like this, n minus 1, n minus 2, like that, okay. So n minus r plus 1 is the case for the last, if I go for r places, okay. Chali. So number of ways of arranging, number of will be equal to number of ways of filling r places, okay. Please check here. N into n minus 1 into n minus r minus 1 will become, actually bacha, please check here, n into n minus 1 into n minus r minus 1. What I'm doing over here, multiplying this with, have a look. So basically multiplying this with n minus r and n minus r in both the factorial, basically in the case of numerator and denominator both. So basically I'm multiplying here n minus r factorial both in numerator and denominator. What I get over here, please check. I'm going to get here as simply n factorial, sir. Simply n factorial, sir. Okay. See this, n into n minus 1 into n into n minus 2 will come. Okay. N into n minus 1 over here. Please check. N into n minus 1 into n minus 2 all the way till n minus r. Okay. Plus 1. What is the next picture? N minus r. We can keep going on, it'll go till, but what? If you want to remove this factorial, it'll go till 1 actually. So I've multiplied this, means it's basically going to be n factorial, okay, in the numerator. And I'll have what, bacha? In the denominator, same thing. This is the formula of your NPR. Okay. So number of arrangements of n different objects taken all at a time will be simply n factorial. Answer will be PNN, or basically NPN. Chali. How come, sir? Can you see this? NPN will become, sir, n factorial upon n minus n factorial, right? And I get this as n factorial upon 0 factorial. How much this was? Remember, 1, right? So I'll get this as n factorial upon 1. What is the answer? Simply n factorial. Have a look, okay? So this is for this part. We have multiplied both numerator and denominator by n minus r factorial. Clear? Let's move on now. Now with repetition, what will happen, sir? I'll have every time first digit also I can take n. Answer will be simply your n power r. There's a total of r places, right? So n into n into n into n. How many times, bacha? R times. That's why answer will be n power r. Okay, number of ways of arranging will be equal to number of ways of filling r places. Nothing but n power r. First place by n ways, second place by n ways, so on till r places will be by n ways. No, that's why n power r. Okay. Chali. Now permutation with when all the objects are not distinct. When they are all not distinct, what will happen, bacha? Think about it. I hope you remember this condition, right? I have taken one of the question like this on this property. Okay. We have also solved a question like this in our board's preparation as well. When the number is repeating in nature, we'll see that and we'll remove it from here. Okay, we'll remove from here. What is the property going to be? So sum of the numbers which are not distinct. Okay, first of all you have to take all the numbers and then divide by the factorial of each of them. Okay, please check here. If A1 objects are of first kind, okay, and A2 objects are of second kind, what are you going to do? You're going to have to add that factorial of that, divide by factorial of each of them. Again, it goes till, you have till R, whatever is the number of, similar objects, okay. What is the meaning of non-distinct, sir? Basically, similar objects, right? Similar objects. So whatever is the similar objects, you're going to add all of that and factorial you have to use for this, and you divide by individual factors of all of them. Okay, please check. So in general, AI objects are of ith kind and I from 1 to R. Then total number of permutations of all A1 plus A2 plus A3 all the way till AR will be given by A1 plus A2 plus A3 plus all the way till AR factorial divided by A1 factorial divided into A2 factorial divided by again till AR factorial. Please check. Okay. Now, very important, sir, circular arrangement. Question can come from this as well. Simple but not difficult is there, but it's there, bacha. So very important, we have only one formula. What is that, sir? So number of circular arrangements of n person is given by n minus 1 factorial. N minus 1 factorial. Why is this, bacha? Think about it now. Each starting point leads to the same circular arrangement, right? So if you take, let's say, a case of 3. I have taken the case of 3. So first is over here, second is over here, third is over here. Okay, so I'll have each each starting point leads to the same circular arrangement, right? Because it's the same circle, okay? Then we have to divide the total by the value n, think about it. So I have here, sir, 3 factorial divided by 3. What I'm gonna get? Have a look. 3 times of 2 times of 1 by 3. 3 and 3 is cancelled. What I get? Simply 2. And I can write this 2 as simply 3 minus 1 factorial, right? Correct, no? Same thing is written over here. Have a look. N minus, so n factorial upon n. This is how we get this value. This is how we get this value, n factorial upon n. Okay, so it will become, what's up? N times of n minus 1 factorial divided by n, and n is cancelled. I have the result as n minus 1 factorial. Reason being, because it leads to the same circular arrangement. Okay, how many times? N times. That's why we have to divide that by n. Okay, chali. So if I have to read this out, the arrangement in the closed loops known as circular arrangement, let there be n persons, a1, a2, all the way till an, are to be arranged themselves around a circular table. The number of circular arrangements of n persons will be given by n minus 1 factorial. I hope this is clear. Let's move on now. Now next is combinations. Okay, I know I might be a little faster in the session because this is what we have to do. Okay, we have to be a little quick in our process of learning the concept. Then we have to move on to questions also. Okay, PU1 syllabus is there, so not much weightage is there. We have to learn this because we want to score out of out. Okay, but we have to prioritize PU2 chapters. We have done that in very detail, but we'll learn this as well and solve questions again. We'll solve PYQs, everything we'll solve. Don't worry. But we have to be a little quick in this, okay, because we have to save some time now. That's why. So let's see now. Combinations. Combination means selection of objects, each of different groups or selections, which can be made by taking some or all of a number of objects irrespective of their arrangements. Very important. This is the word. Irrespective of their arrangement, means order does not matter. Of course, you have to choose something, select something, okay? So that is there, but you don't have to worry about their arrangement. That is called as combination. Okay, so selection has to be there, but without worrying about the arrangement. Okay, how is the order? That is not a concern. The number of ways in which we can select r things at a time from a set of n different things is given by NCR. Please check here. It becomes, so have a look, n factorial upon, think about it, n minus r factorial times r factorial. So we are taking out the arrangements also. We're taking out the arrangements also. Please check here. In the case of permutation, we had have a look, we had NPR, right? Please check n upon n minus r factorial over here. You can check, okay? But in this case, we have to include the arrangements also. That's why they were not divided by r factorial. Have a look. But in this case of combination, we have divided by r factorial because we are leaving your number of ways to replace this. So arrangement is removed, sir. The order is not concerned, that's why I removed from here. So basically, if you want to see the relation between NCR and NPR, have a look. I can write this as NCR equals to, this will become NPR only, divided by r factorial. So basically, I have NPR equals to NCR times of r factorial. That's the relation. Please check. NPR is equals to NCR times of r factorial. Is that clear? Makes sense also, no? Because in case of NCR, we are leaving out that order part. So we're going to include that. Once you do that, you will have the NPR as well. Okay? Chaliye. Let's move on now. Some properties that we have to remember. Questions can come on this. Still, this property, very, very, very relevant to us. Questions can come on this. Okay? What is that? The number of ways of selecting 0 or more things, 0 or more. Okay? From n different things or objects will be given by NC0, NC1, NC2 all the way till NCN, and this is equal to 2 power n. 2 power n. If I replace this 0 by r things, okay, at least r things, I'll have the same result like this, NCR plus 1 all the way till NCN, all the way till NCN. The number of ways of selecting at most r thing, again you start from NC0 and go all the way to NCR. NCR. Please check here. At most r means it'll end up at NCR. Start from minimum value, which is 0. Choosing minimum of 0 and going all the way till r. Okay, out of the n objects given to you. Out of the n different objects given to you. Please check. Alright. Number of ways of selecting 0 or more things from n identical. Bacha will become n plus 1 simply. N plus 1. Because if you have n identical objects, and you have to choose 0 or more. So of course you can choose what? 0 means nothing, you can choose. That one is there, and I can again choose any of them. So n. So n plus 1 will be your number of ways of selecting 0 or more. Have a look. The number of combinations of n different objects taking r at a time, okay, when each of object may occur once, twice or thrice like that up to r times will be given by n plus r minus 1 cr, okay, n plus r minus 1 cr. Okay, this is the formula. Again you have bacha the total number of ways of dividing and identical. Okay, Achan, one more thing I want to say, there is a proof for this as well. There is a proof for this. We can prove this part, not difficult at all, okay, but not useful for us right now for examination purpose. If you remember this, no, okay, if you want to do one thing, go and learn this proof as well, okay. If you want, I can teach you that later, not a problem, but I'm telling you, not useful. The proof is not useful to us, but this property is very, very useful to us, okay. The total number of ways of dividing n identical items among r portions, each one of whom can receive 0, 1, 2 or more, will be given by n plus r minus 1 c r minus 1. Please check c r minus 1. All right, let's move on now. Some properties of again your combinations, please check, and permutations also. Have a look. This is what I wrote now. I taught you this part right now. NPR equals to r factorial times of NCR, also equals to n minus 1 PR plus r power n minus 1 PR minus 1, okay, PR minus 1. So r times of n minus 1 PR minus 1, okay. Let's move on. We have this property, remember, very, very important. NC0 or NC1 will be always 1. Always 1. Useful in the case of binomial theorem also, right? So NCR equals to NC n minus r, okay, from 0 to, please check here, 0 to n, 0 to n. So this property is valid, no? Same, actually we have used this, this relation to get the first result. Please check here, from 0 to n, right? If you had 0 over here, you had n over here. Put here r as 0, put here r as 0, you're going to get the same result. NC0, NCN. Correct or not? Okay. Third one, NCR minus 1 plus NCR will be equal to n plus 1 CR, okay. Fourth one, NCR equals to NCS provided that S or R are equal or the sum is equal to n. Bacha, same concept. This and this is again same result. Please check. Okay. So basically coming from here, bacha. Coming from here, sir. Second is being used over here. Please check. Yeah. Because if you add this, sir, R plus n minus R, how much is that going to be? Simply n, na? That's what they're saying. Either R equal to S or R plus S equals to n. Either R equals to S or R plus S equals to n, okay, same thing here. Please check R plus n minus R. The property number 2 and 4 are equal. The property 2 comes from the property 4 only, okay. So we have NCR equals to n minus R plus 1 upon R times of NCR minus 1 factor, okay, basically not factorial, NCR minus 1. Again R varies from 1 to n, bacha. And the last one we have NCR equals to n by R, n minus 1 CR minus 1, n by minus 1 CR minus 1, okay. Again R varies from 1 to n. Properties are important, sir. Yes, you have to learn these properties and solve questions on this, okay. You have to solve the questions on this. Properties are very, very important, can be used directly. Now we have some questions to solve. Let's solve these questions and quickly complete our chapter permutation and combination from PU1, okay. Chaliye. So how many numbers are there between 99 and 1000 having 7 in the units place? Think about the numbers, bacha. Between 99 and 1000 you'll have only 3 digit number, right? No, starting from 100 and all the way till 999, but they can't take 99 and 1000, no, because they're talking about between, right? So it has to be taken between those. You have 100 and 999, okay. So we are looking for that, means we are looking for, bacha, filling of 3 digit space. All right, sir. So they are saying that having 7 in the unit space means it has to be only have 7. How many ways, bacha, we can pick 7 out of it? Only one way, no? Can you pick any other way? You have to pick only 7 in the last digit or unit digit. You have to be only one way to do that. Great, sir. Next, picking the first digit, let's say. You can pick this first digit in terms of 9 ways. How come, sir? Please think. 0, 1, 2, 3, all the way till 9 we have, right? 0, 1, 2, 3, all the way till 9 we have. But can we take 0 over here? Can we take 0 over here? We cannot. If you do this as 0, if you take this as 0, it will become 2 digit number now. Okay? That's why we have only 9 ways. 1 to 9. So 9 ways. What about this, sir? I can take total of 10 ways over here. Correct? Now I can take 0, 1, 2. For this I can take 0, 1 all the way till 9 also, na? 0, 1, 2 all the way till 9 also. It means for the first digits, for the first, basically at the hundredths place, I can take this as 9 spaces. 9 digits can be taken. For this I can take only total of 10 digits. For this I can take only 1 because we want 7 at the end. What is my answer going to be? 9 into 10 into 1. Fundamental principle of counting. Answer will be 90, sir. Actually, option C is correct. Use of fundamental principle of counting using multiplication. Please check. In a class there are 27 boys and 14 girls. The teacher wants to select one boy. So we have two slots, one boy and one girl, right? Yeah. To represent the class for a function, in how many ways can teachers make this selection? So we have total of 27 boys, right? So I can choose any of them to 27 ways. Right, and same goes with the girl also. So 14 girl. Check the answer. 7 4s are 28, right? So number ending with 8. Option A is correct. Sometimes you have to be smart also, bacha. You can see 7 into 4 will be 28, right? So I have to end this number with 8 only. There is no other possibility. Only one is there. So answer is option A. Please check. You can multiply, completely, of course, but not relevant. You can do this way as well. Okay. Question number 2 is done. Question number 3 now. Determine n if they have given equation in terms of combinations. We have to find the value of n. Okay, let's see. 2n factorial divided by 2n minus 3 factorial, okay, times of 3 factorial divided by, have a look, I have here n factorial upon, please check, I'll have n minus 3 factorial times of 3 factorial equals to 12 by 1. 12 by 1. Correct? Okay. So I can see here 3 and 3 factorial cancels. Now I'm going to expand the numerators. So I'll have this as, please check, 2n times of 2n minus 1 times of 2n minus 2, okay, times of 2n minus 3 factorial. Na? That's how I can expand the this factorial. 2n, then 2n minus 1, then 2n minus 2, then 2n minus 3 factorial. I'm writing here factorial, okay. I can write this 2n minus 4 like that till 1. I don't have to do that, no. Simply 2n minus 3 factorial is good enough, right? Why, bacha? Because I have the same thing in the denominator, that's why. What I have left over here? 2n minus 3 factorial divided by this whole, again, there's another fraction. I can write this n factorial again as n times of n minus 1 times of n minus 2 times of n minus 3 factorial. Same way as we did for 2n minus 1 2n factorial, from 2n to 2n minus 3 factorial, same way I'm doing n to n minus 3 factorial because I have n minus 3 factorial over here. I hope this is clear. Write this n minus 3 factorial. Again, this is whole thing equal to 12 by 1. Now see this magic. Everything will be cancelled. We'll have a simple statement. This bacha will be cancelled again. Again, I'll have this also cancelled. Okay. Now check this out. I have here, what I have, bacha? I have a 2n times of 2n minus 1 times of, I can take 2 common, no, in this 2 term, it will become 2 times of n minus 1 divided by, I have here n minus 1, n minus 2, okay, equal to 12 by 1. N into n minus 1 into n minus 2 equal to 12 by 1. Have a look now. N minus 1 and n minus 1 is cancelled, okay, and n is also cancelled. What I get now in the numerator, 2 into 2, which is 4 times of 2n minus 1 divided by n minus 2 equals to 12. 4 3s are 12. I get 2n minus 1 equals to, please check here, 3 times of n minus 2 giving me 2n minus 1 equals to, I have 3n minus 6. Bring this 6 over here and this 2n on this side. I get here 6 minus 1 equals to 3n minus 2n, giving me n value as simply 5. Simply 5. Option A is correct. Please check. Excellent question. Not difficult at all. Simple but good question. Okay. So this is done. Third is also done. Have a look. Fourth one now. If there are 6 periods in each working day of school, then the number of ways that you can arrange 5 subjects. Okay. So basically, bacha, I have, let's say 6 periods. No? So 1, 2, 3, 4, 5, 6. Okay. So I can go subject 1, subject 2, subject 3, subject 4, subject 5. Now, what can happen? Either subject 1 can come, or 2 can come, or 3 can come, or 4 can come, or 5 can come. right? Basically in any of the cases I will have bacha one subject repeating. Agreed? It means if I take subject 1, I have subject 1 coming 2 times. If I take subject 2 over here, I'll have subject 2 coming 2 times. So whichever case I take, I will have any of the subject repeating in nature. Okay, so basically my arrangement, if you check, it will become so total of 6 periods, so 6 periods by 2 factorial. Correct, sir? Why 2 factorial bacha over here? Think about it. Because whatever case I take, for the last session, I have a subject which will repeat itself. Correct, na? Because first 5 I have taken subject 1 to subject 5, but last is a free period. So any of the subject can come. 1 can come, 2 can come, 3 can come, 4 can come, 5 can come. Means I have to have the repetition. That's why dividing by 2 factorial. Okay. Now into this is enough. No, so we have to take this for the first, second, third, fourth, 5 subject. Means basically 5. 5 C1 is simply 5. No, this will be 5 C1 actually. It become simply 5, sir. Okay. So please check what I get now. I get this as 6, right? So I get bacha 6 into 5 into 4 into 3 into simply sir 5 over here. So I get over here, please check, 6 into 5 is 30. 30 into 5 will be 150. Okay, into 12, right? Yeah, 12 into 15 is going to be 180. Answer is 1800. Option C is correct. Option C is correct. Please have a look. Okay, this is done. Let's move on now. Good question. Question number 4 was very good question. Okay, understand this because the repetition of the one of the chapter subject is there. No, that's why we have to divide by 2 factorial. Remember, identical element. There was a concept like this I taught you. Okay, this one, a1 plus a2 by a1 factorial into a2 factorial. That one was there. Okay, so whatever is coming twice, we have to repeat that. So we have to remove that. That's why divided by 2 factorial. Okay. So last question of the day we have, in how many ways can a student choose a program of 5 courses in 9 courses? Okay. So we have to choose from total of given are 9 courses. Okay. And he has to choose 5 out of this. And 2 are compulsory. 2 are compulsory. Okay. What it means, sir? It means actually either you think like this, out of 9, 5 you have to choose 2 are compulsory, or I can do what bacha? Out of 7 he has to choose 3 only. How come, sir? Bacha, total 9 is there, but he has to choose 2 compulsory. Means that has to be chosen. Means there's no combination in that. We don't choose that. That's going to be very, very simple, right now. No choices given to that because you have to choose 2 compulsory. So that is gone. So out of 9. He has lost bacha 2, that's why 7 over here, and out of 5 he has lost bacha again 2, that's why 3 over here. What I get now? 7 C3. It will become 7 factorial upon, please check, 3 factorial times of please check 4 factorial. Okay, so I get here, have a look. So I get here 7 into 6 into 5 times of 4 factorial divided by what I'm getting, please check, 3 factorial into 4 factorial. This is cancelled right now. Okay, so I have this as 7 into 6 into 5 by 3 factorial only left will be again 6 only, right? 3 factorial is nothing but 6. 3 into 2 is 6. So again cancels. My answer is going to be 35. 35. Option B is correct. Option B is correct. Have a look. Done. Option B is correct. I can repeat this. Since he has 2 compulsory subjects, it means out of 9 I can remove 2 because there's no combination for that. It has to be chosen. So 2 is removed. So I have total of 7 left. Now out of 5 that he has to choose, he has already chosen 2. It means what is your remaining subject to choose 3. So from the 7 you have to choose any 3. From the 7 you have to choose any 3. The answer will be 7C3. So the calculation, please check, answer is coming as 35. Done. Okay, this completes your chapter permutation combination. So I hope you enjoyed that. So first we'll see all the concepts that is there, formula that is there, and then we'll move on to your question solving. So let's quickly start the session. So what we have over here for us is, if you look for the first thing, sequences. Okay, so sequence is a collection of numbers arranged in definite order. Okay, and obtained in succession according to the some definite rule. Okay, some definite rule. What it means, bacha? It means, for example, I can have a sequence like this: 2, 4, 6, 8, so on. Okay, I can have a sequence like this: 1 square, 2 square, 3 square, like this. There's a pattern of numbers, right? Whenever you have some definite rule for a given sequence, we can call that to be, okay, certainly a sequence. Again, you can see here, this is nothing but arithmetic progression. This is nothing but square of the natural numbers, square of the natural numbers. Okay, so whenever you have a sequence in terms of geometric progression, how do you define that, sir? So how do you define that? It means if I have a sequence like this, let's check. So if I have a sequence like 3, 6, 9, okay, then I have excuse me, yeah, no, this is incorrect. This is AP only, right? This is not GP. So 3, 6 is there. Then we have next is 12, 24, 48, and so on. 3 to the 6, 6 to the 12, 12 to the 24, 24 to the 48, and so on. We call this type of sequence as geometric sequence or geometric progression. Please check. So we have two types of sequences, bacha, where we have finite and infinite. Means whenever the number of terms in the sequence is fixed, we call the sequence to be finite sequence. Whenever we have fixed a finite number of terms in the given sequence, okay, and whenever we have infinite number, which means basically we can't find the number of terms there, okay, is undefined or somewhere is not given to you, that type of sequence is called as infinite sequence. It's called as infinite sequence. Moving on. So now talking about geometric progression, okay, so in this bacha, very special. So we have a sequence like this. I wrote example over here now. So we had 3, 6, 12, 24, 48, and so on. Means whenever you have a constant product like this, or also called as constant ratio, okay, so 3 into 2 is 6, again into 2 is 12, again into 2 is 24, so on. It means if the ratio of the successive terms remains constant like this, please check: 6 by 3, 12 by 6, 24 by 12, and so on, always equal to 2. It means that type of sequence will be called as geometric sequence. Okay, geometric sequence. Please check. So I have over here A, AR, AR square, and so on. What is A called as? A is called as first term. First term. Whereas R is called as common ratio. Alright, first term and the common ratio. Okay, now this is very simple, right? You can add like this. Some of the n term will be given by, please check, A plus AR square, like that. And what is bacha general term of this GP? This will be given this way, bacha. Please check. It will become A times of R, not A power, I said A times, no. So A times of R power n minus 1. A times of R power n minus 1. Please check. If I put n as 1, it will become bacha R power 0, no? It will become A times of R power 0. How much is that? Simply A. If I put n as 2, it will become A times of R power 2 minus 1. How much is that? Simply AR. If I put n as 3, it will become A times of R power 3 minus 1. How much is that? AR square. Same thing is over here. AR square, and so on. This AR n minus 1 is called as general term of the GP. General term of a GP. Please check. Extremely important. Okay, all right. Insertion of single geometric mean. Okay, so first of all, what is geometric mean, bacha? Basically, if I have, let's say, two numbers A and B like this, there exists a number G in between A and B, which will be, if you put it over here, what will happen, bacha? It will create a geometric progression. Okay, means G will be the geometric mean of the terms A and B, and write G as root of AB. This is given by root of AB. Okay, now insertion of a single geometric mean between two given numbers. If we have A, B, C as any three numbers in GP, then your B will be given by, very simple, this B is called a geometric mean and is given by root of AC. It's given by root of AC. Please check. Given by root of AC. Same thing I've written over here. G as root of AB. In this case, you have taken ABC, no? That's why B as root of AC. The middlemost number, no? The middlemost number will be the root of, will be equal to the product of the root of the first and last. Okay, chaliye. Insertion of n geometric mean, very important. n means 3, 4, 5, 6 like that. Okay, so n geometric means between two given numbers to you. Okay, let's say you have given number as the number is given as, please check a and b, right? Two numbers given as a and b, and you are inserting n means, so g1, g2, g3, g4 up to gn is the n geometric means. N geometric means. Okay, when you insert that, what you're gonna get, please check, you'll have the gp as a, g1, g2, g3, so on till gn comma b. So how many terms you have, bacha? Now how many terms you have? Please check over here. You have n geometric means, so n, and then you have a and b also, right? So plus 2. Total number from becomes n plus 2. Okay, then you can write again, this b will be given by what, bacha? The formula of, what is this given as? Please check, this is the general formula, the general term formula of your GP, that a times of r power n plus 2. Over here the n becomes n plus 2, right? How come n plus 2, sir? Total of n g values, right? g1, g2, g3 up to gn, and we have a and b also, that's why n plus 2. Okay, so if you write n plus 2 minus 1, you get this as n plus 1. This is getting as, please check, r power n plus 1. Okay, and this a can be taken over here. So I'm getting b by a equals to r power n plus 1, and if I have to find the value of r, I have to take the root of what root, bacha? N plus 1 root of the value b by a. Expression for your r. What is r, sir? Common ratio. What is r? Common ratio. Okay, moving on. I hope this is all clear. Moving on now. So if you have to write g1, think about it. First term was a, second term was g1, third term was g2, so on till second last term was gn, and last term was b, right? So if I'm writing, let's say g1, I can write this g1 in terms of a as a times of the common ratio r. The common ratio r, what's the common ratio if you remember? It was b by a to the power n plus 1th root. N plus 1th root. What is n value here, bacha? The number of geometric mean that you're looking to find out. Okay, n represents number of GMs. Okay, number of geometric means. Please check. N represents number of geometric means, g1 to gn. Okay, b by 8 power 1 upon n plus 1. Okay, if you look for g2, what will happen, bacha? You'll have 2. If you look for g3, you'll have 3 over here. So if you look for gn, you'll have n over here. You'll have n over here. This is going to be your general formula for the n geometric mean between any given two numbers a and b. Okay, any given two numbers a and b. Okay, now so if g1, g2, gn, b n geometric means between two quantities. Okay, and a and b, then g1 g dot g2 into g3 dot gn will be equal to, bacha, always g power n, always g power n, where g is given by, what is g given by? Root of ab. What is this, bacha? This is geometric mean of a and b. Single geometric mean, not n geometric mean. Okay, one geometric mean between a and b will be given by root of ab, right? We just learnt it. So that to the power n. If I have, let's say, n geometric means, no, 1, 2, 3 all the way to n, you'll write this value root ab power n, sir. Power n, sir. Okay, please check. Now what we have, relation between am and gm. Relation between am and gm. What is am, sir? Arithmetic mean. So if I have two numbers, let's say ab, I'm writing here, let's say a number a. What is this, sir? Arithmetic mean between a and b. This a is given by a plus b by 2. Okay, you already know the gm, right? If I have a, g and b, g is given by root of ab. The relation given between them is this, bacha. A is greater than equal to g, greater than equal to g. Please check. Okay, a is greater than equal to g from here. How come, sir? A minus, if you're writing, no, write this value, you get this as whole square, no? It'll become what? Please check. It'll become, sir, root a square. You have b as root b square. Okay, and then you'll have root 2 times of root a root b. This will become 2 times of root a root b. So we can write this as, this whole term will be root a minus root b the whole square by 2. It's a whole square, right? Either 0 or positive. That's why either 0 or more than 0, so positive. From here, if you move the g on this side, no, it will become what, bacha? Please check. From here, what we're getting? A minus g is either 0 or positive. From here I get A is greater than equal to G. Right? How did we get it? Just take the LCM, it will become 2 root AB now. So I can write this 2 as 2 into root A into root B. Okay? I have root A square, root B square, so I get x square, y square, and then minus 2xy. So x minus y the whole square. Upon 2 will be there because LCM is 2. Please check. Okay? So this is the relation between AM and GM. Now, infinite GP and its sum. Whenever you don't have the n value known for a GP, you have infinite number of terms. Okay, you have a infinite number of terms. Then we write this simply as A upon 1 minus R. S infinity is given by A upon 1 minus R. What is A value, bacha? The first term. What is R, sir? Common ratio. R is common ratio. And of course, you should have this condition true. It's given by A upon 1 minus R. Please check. Very simple. Now, let's look at the questions. So, question number 1 we will solve. So, product of 3 geometric means between 4 and 1 by 4. 4 and 1 by 4. Please check. So, let me take the geometric means to be, I have a G1. I can make it better. 1 second. Yeah. So, I have G1, G2 and G3 with the geometric mean. Okay, why only 3, bacha? Because we have, they're saying that we're talking about only 3 geometric means. Okay, that's why. Now the numbers is given right here: 4 comma G1 comma G2 comma G3 comma 4 is there. No, last one is 1 by 4. The number A is 4 and number B is 1 by 4. Okay, again you can use the formula that is given to you. This one, R equals to B by A power n upon, 1 upon n plus 1. Excuse me, 1 upon n plus 1. Yeah, 1 upon n plus 1 you can use, or we can simply see this. Please check from here. Okay, we know the first term, we know the last term, right? So right here, nth term is given by A times of, we don't know the common ratio, R power n minus 1. What is the n value, bacha? Please check here. What's the n value here, sir? N value is 5, no? 3 geometric means and 2 terms in the beginning and the last. So we have 1, 2, 3, 4, 5. So n value is nothing but 5. Let's substitute it. So I get A5 equals to, what is the first term? 4. 4 times of R we don't know. 5 minus 1. How much is that? 4 only, no? 5 R power 5 minus 1. N is 5, so 5 minus 1. Please check. A5 is how much given this as? I have this as 1 by 4. So right here, 1 by 4 equals to, we have 4, R power 4. Bring on this side, I get 1 by 16 equals to R power 4, giving me value of R as, please check, 1 by 4th root of 16. Okay, so I get R value as 1 by 2. Now please check. If my first term is 4, half of this is 2, half of this is 1 by 2, half of this will be, half of 2 will be 1, no? Yeah. And half of this will be 1 by 2, and then you have 1 by 4. Please check. R is 1 by 2, no? So 1 by 2 of 4 will be 2, half of 2 will be 1, and half of 1 will be 1 by 2, and so on. Okay, what are they asking? Product of the means. So take the product of these, you get 2 into 1 into 1 by 2. 2 and 2 is cancelled. Answer is 1. Option C is correct. Question number 1, option C is correct. Okay, now we'll move on to question number 2. Alright, we'll move on to question number 2 now. So question number 2 states, please check the arithmetic mean of two numbers x and y, okay, is 3. What it means, sir? So we're talking about AM, right? It means x plus y upon 2 is given as 3. It means x plus y equals to 6. This is my equation number 1. Other one, what do we have? Geometric mean is 1. Now GM is also given. It means root of xy is 1. Okay, from here I can square on both sides. I get xy equals to simply 1 square, right? And that will become simply 1 only, no? If you square on both sides, what will happen? You'll have xy equals to 1 square, which is nothing but 1 only, right? Now what are they asking us? Value of x square plus y square. Value of x square plus y square. Very simple, sir. We have this value now with us. Just take the whole square on both sides. What are you going to get? X square plus y square plus 2xy equals to 36. Now put the values that we know. 2 times of 1, 36. So x square plus y square equals to 34. Option is option A. Option A is correct. Option A is correct. Simple problem, very simple. Chaliye, next one. Okay, this is the last question I've taken for your sequences and series. We'll complete this session. Quick session for your sequences and series. Again, we'll take more questions in your coming sessions on what do you call? If you see, we have more questions coming in our various series which is coming on our platform. But right now, this is your question. Please check. So the area and perimeter of rectangle are AP. Area and perimeter of rectangle are A and P. Okay. So let's say the rectangle has the sides as x and y. Okay. So area is given by xy and perimeter is given by 2 times of x plus y. Okay. So I'll just take this aside. It will become p by 2 equals to x plus y. Okay. So we have two conditions with us known now. We are asking for P and A, right? Relation of P and A. P is perimeter and A is the area. Okay, one more thing we know. AM is greater than equal to GM. So if I have number x and y, what is the AM of x and y, bacha? X plus y by 2. Okay. And GM will become root xy. Excuse me, root xy. Now put the values we have. We have x plus y as p by 2. So right here p by 2, this whole thing by 2 greater than equal to, this will become, bacha, please check. I can write it like this only, root xy right, as of now. Okay. And now it becomes so p by 4 greater than equal to, excuse me, root xy. So I get p is, excuse me, p is greater than or equal to, please check, 4 root xy. Take the whole square, it will become p square is greater than equal to 16 xy. Square will cancel the root, so 16 xy. Alright, so I have p square greater than equal to 16. What's the value of xy, bacha? Simply the area A. So right here 16a. So this is, I think, should be a result. Option D is correct. Option D is correct. Please check. Have a look. This is clear. Option D is correct. Okay. This completes your questions, your concepts in the chapter sequences and series. Okay. If you want something else from my side, let me know that as well. So let's learn one short session for linear inequality. So we'll solve all the questions. So I've taken, I think, 3 problems which are very good. We'll solve those 3 questions and we'll learn every concept which is there in the case of linear inequality. So please have a look. So we have, first of all, to understand what is inequality. Okay. So in the inequality, bacha, we have 4 categories. For example, we have this symbol. Excuse me. I'll just change the color to make it more visible. So first we have this symbol, then we have this symbol, then we have this symbol, and the last one we have this symbol, right? So their name for it, this is called as strictly decreasing, means less than. Okay, strictly less than. So less than we write for this part, excuse me, less than we write for this. Okay, similarly for the second one we call it as greater than, and we have for this part less than equal to, less than, also we write it as equal to. Means we have equality also present in this. If you look very carefully, we have less than, but we also have this sign which represents equal to. For example, it means that if I write a let's say variable x less than equal to 5, okay, x less than equal to 5, it means that, so all the values of x which is less than the value 5, for example, if it is, let's say, only natural numbers, okay, if let's say x is only natural numbers, then I can say bacha 1, 2, 3, 4, all numbers which is less than 5 and also 5 because of the presence of the equality over here, less than and equal to. This is the value of your x. Whereas if I change this statement to x less than 5 and right here x is only a natural number, then answer will be x equals to, please check, 1, 2, 3 and 4. 1, 2, 3 and 4 will not have 5 in it. Because of the presence of equality, we mentioned that as well. Okay, so this is clear. So we can write this, we can write the combination of the inequality also. For example, we can write x is less than 5 but more than 0, but more than 0. We can say over here equal to also, we can say over here also equal to, or without that also is okay. Means any combination, whether it is with less than only or with less than equal to also, okay, it's all right. Okay, so check here, less than only or less than equal to, both combinations is present over here. I can take same case with greater than also, greater than or greater than equal to, both is okay. Okay, so we make the equations from there and we'll solve those inequalities. So whenever we have equations present in it, we call it to be linear, or if it is quadratic form, usually we don't have it in this chapter. We have the linear form, means when the power of the variable is 1 and that is present with not equal to sign but inequality sign, is called as linear inequality. Think about this, 2x plus 7, 2x plus 7 less than 3, less than 3, it's called as linear inequation. Of course there is only one variable over here, that's why written here linear inequation in one variable. I can have more than one also. I can have 2x plus y plus 7 less than equal to 3. Okay, so there can be more than one variable also. Remember we use this, you already learned PU2 now. We use linear equations in two variables, linear inequations in two variables in LPP, right? In LPP we have inequations in two variable, right? Okay, so please check how to write this bacha. It will become 2x plus 7, I can change on this side, so less than 3 minus 7, you have 2x less than minus 4, we have x less than minus 2. Okay, don't worry about it, we'll learn how actually we take up these questions. Okay, so this is just to inform you one of the ways to solve this question. I have taken the steps to involve to solving inequations, and again don't worry, we'll have more questions coming your way to practice in the inequalities also. Today I have taken very limited amount of questions because it's about more learning the concepts today, but again you'll have sessions just for practicing the questions as well. Okay, so please have a look. Again notice there, inequalities involving signs less than or equal to, sorry, less than, greater than are called as strict. Please check here, the word is strict inequalities, means it has only one sign, less than, not equal to is present over there. But if you have bacha this cases, this is not called as strict inequalities because it has both less than but also equal to condition present over here. Okay, as already explained to you. So statement between two expressions involving a single variable x with highest power 1, very important for linear inequations in one variable. Inequality is going to be either of them. In the case of inequality, you can write both, either greater than or less than, or greater than equal to or less than equal to. I can use any of these four cases. It's called as linear inequations. Again, if it is just less than or greater than sign, we call it to be strict inequality. Alright. Now we have general rules for solving linear inequations in one variable. Rule 1 is equal number may be added. Basically the ways to solve it in the case of equations as well. For example, I have x less than, let's say, 3. Okay, this is a given inequation. I can add equal number, means I can add here x plus 2 and 3 plus 2. Okay, same way I can add here x minus 2 and 3 minus 2. It will not change anything. Okay, basically equal numbers, whether it is positive or negative, can be added. Very important, the word is added to or subtracted, also written here now, from both sides of an inequality without affecting the sign of the inequality. Sign of the inequality means bacha, less than sign, greater than sign, less than equal to sign, or greater than equal to sign. This is the meaning of sign of inequality. Okay, so without changing that, if you are adding it, whether it is or positive or negative value, no change in the sign of the inequality. But if you are dealing with multiplication and you are multiplying with a negative sign, please check here, if you are multiplying with a negative number, multiplied with negative number, what will happen? Inequality will reverse, sir. Think about it. So if I have, let's say, x is greater than 3, x is greater than 3, and I want to multiply minus 2 to both sides. So I'll have minus 2x minus 6, okay, but inequality will reverse. It was greater than, it will become less than. If it was greater than equal to, it will become less than equal to. I hope you understand that. If you are multiplying with a negative sign, what do you multiply with, sir? Minus 2 I multiplied here. No, it's a negative number or not? Yes, it is. If you're multiplying that with a negative number, what will happen? Inequality will reverse. Please check here. Reversal is like this. Greater than equal to becomes less than equal to. Same way, opposite is also there. Okay, and same goes with strict inequality as well. Opposite is also true. Okay, I hope this is clear. So this is how it works in the case of multiplication. But if you have positive, no, let's say I'm multiplying over here. I had x greater than 16. I want to multiply with 1 by 2, let's say. I write here 1 by 2 x. And 1 by 2 of 16 is how much, sir? It's going to be 8, right? Inequality will change? No. So it doesn't matter whether it is less than 1 or more than 1. That will not affect the inequality sign. Only if it is positive or negative it will affect. Okay, so if you take 1 by 2 also, if you multiply, it's a positive number or not? Yes, it is positive. It remains same. Okay, greater than only is there. But if you take negative value, it will reverse. So understand this, only in the case of negative value inequality will reverse. Rest all other cases inequality remains itself. Okay, so I hope this is clear. Let's move on now. So this is clear, right? Yeah. Now we have graphical representation of the intervals on the number line. Okay, again for the x-axis we'll be talking about. So x belongs to, the symbol is belongs to including a. This means, sir, including, right? Close bracket means including a up to infinity. How do you write, sir? So you'll take a number line again. You'll have here negative infinity. You'll have here positive infinity. Somewhere will be the number a, of course. From a you'll put a close or dot. Okay, not visible. I can change the color. Okay, you'll put a close dot, a full circle dot, and then so the sign from a to positive infinity. No, so from a to positive infinity like this. Arrow will go till positive infinity, sir. Please check. I can show on the number line also. Okay, just to show the color difference, I've shown it upward. Okay, so I can show on the number line also like this, basically like this on the number line, but not visible. No, that's why I've taken the arrow upwards and shown you. All right, so we'll just delete this. Okay, let's move on to the second case. What we have, x belongs to negative infinity. Again, please check, negative infinity to a. Okay, how right, bacha? Of course, the number line will come. You'll have this side as negative infinity, this side as positive infinity. There's a number a somewhere. And this case we're talking about negative infinity to a, so we'll go like this. Okay, so we'll there's an open sign here, no, so we'll put here open circle and go towards this, go towards this. Where can, sir, why can't we go from here to here? Can you actually get a point over here, then point the arrow? Can you mark somewhere and point the arrow? You can't that, no, you can't do that, because there's no definite point of negative infinity, is there? Means of course arrow has to be pointed from open a to in negative infinity. I hope this is clear. Okay, next one, a to b. This is very simple, sir. We'll have two definite numbers, a and b. So right here a, b, of course, and between a to b, right? So please check here, both are open brackets. It means open, and then the line joining them. That's your answer. Okay, of course all the numbers between a and b except for a and b. This is the answer, sir. A and b will be open, bacha. What next is there? Please check. Next case is a and b is closed, sir. So we'll write like this. I put here a, I'll put here b. A and b is closed. Now please check the bracket. It's closed, right? So what I'll do, I'll just put here full dot, close circle, and line joining it. This is your answer for a and b dot. Again, both are closed, means both are included, sir. Okay, chaliye. What else we have? Next one, in negative infinity to a. Okay, negative infinity, I have a somewhere, I have b somewhere, I have positive infinity. Okay, so negative infinity to a, right? Chaliye. So we'll show this. A is included, please check, close bracket. So I'll put here full dot and goes like this. Okay, What we have? B to infinity. Again, B is open, right? Over here, B is open, sir. Please check. So I'll put here B open circle and going like this. Okay, going like this. You can see that. Okay, so these are some cases. This is again case 5. Okay, so this is clear. Now this completes your graphical representation part. Okay, note if the inequality involves less than or greater than symbol, we draw filled circles. Remember, less than equal to is there or greater than equal to is there. Wherever is the point, no, we draw a filled circle, sir. Okay, either going like, sorry, less than, na, yeah, like this only. Greater than means like this only, right? Okay. And if you have just this symbol, greater than, this is less than equal to, greater than equal to. If you have only greater than, we'll write here, please check, open arrow. Less than means open arrow. Got it or not? Yes, it is. Okay, so I have already explained this to you. I'll move on to questions now. So we have question number 1. Let's solve this question, get the answer. What is it, sir? We have this is compound inequality, right? So we can cross multiply to this. Please check. 7 into 2 less than equal to 3x plus 11, 13 into 2. Now we'll take each of the inequality one at a time. Okay, we'll take each of the inequality one at a time. Please check. So for the first one, I have 7 into 2 is 14. I'll write it later. Other one, please check. I have 3x plus 11 less than 26 now. 13 into 2. 13 into 2 is 26. Check here. I have 14 less than equal to 3x plus 11. Move this 11 on this side. I get 14 minus 11 less than equal to 3x. From here I'm getting 3 is less than equal to 3x. It means I can divide this both 3 and 3. I get 1 is less than equal to x. Means x is greater than 1. So x is greater than 1. Greater than equal to actually. Okay, what about this side? I can write here 3x is less than equal to 26 minus 11. So 3x is moving 11 on this side. Okay, or basically subtracting 11 on both sides. Remember the first rule, I can add or subtract same thing on both sides without changing the inequality. Okay, so I get 15. So I get x is less than 5. Greater than 1 and less than 5. X is greater than 1. Please check. And x is less than 5. Plot the number line. 1 here, 5 here. Greater than 1 means closed 1 and less than 5. So again closed is there. Closed the arrow between them. 1 to 5 both closed. Option B is right now. 1 to 5 both closed. Please check. Option B is right, sir. 1 to 5 both closed. Option B is right. Okay. Question number 2 now. Solve 3x plus 9 less than equal to mod of minus x plus 29. Forget about this, sir. Whenever you have this case, no, k is less than equal to mod of a. How do you solve this, sir? We have two conditions. K is greater than equal to minus a and less than equals to a. You know this property, right? Whenever we have condition like this, we write it in this form of the inequality. Removing mod, we'll get more than minus a and less than a. Okay, now apply the same condition. So I have 3x plus 9 greater than equal to minus of this value, no? It will become 29 minus x. And for this side, we will have same thing, no? Remains unchanged. If this value itself I am calling which are inside one is a, minus a means negative sign of this, means x will become positive and 29 will become a negative. Sorry, yeah, excuse me, I wrote the same thing, no? I wrote the same thing, x minus 29, right? It's the same thing actually written over here. I made a mistake, so x will be positive and 29 will be negative. Okay, now I'll solve the inequalities one at a time. We have this together and this together. Let's solve it. What I get? So I'm getting here x minus 29 less than equal to 3x plus 9. First one. Second one is 3x plus 9 less than equal to minus x plus 29. Okay, move this x on this side and this 9 on this side. So I get here 3x plus x is less than 29 minus 9. Okay, so I get here 4x is less than 20. So I get here x is less than 5. So not less than equal to, of course. Okay, it's less than equal to. On this side, what I get, bacha? I'll move this x on this side and this 9 on this side. I get again minus 29 minus 9 less than equal to, I have 3x minus x giving me this as 2x. Again, I have over here minus 38. Cancel this 2 with, I get 19. I means I'm getting x is greater than equal to minus 19. Okay. So if you plot on the number line, what I'm getting, bacha? I have minus 19 somewhere over here, 5 somewhere over here. Both are included, so big closed circles and between them. Okay. Answer is x belongs to, please check, minus 19 close to 5 close. Greater than minus 19, less than 5. Greater than minus 19, less than 5. Option is D. Option is D. Please check. Option is D. For this one, I had option as B. Done. Question number 3 now. Solve 5 times of, I hope this is clear, right? Please check. This is clear? Okay. So solve 5 times of 2x minus 7. Okay. And 2 inequalities are there. We'll solve it separately. What I'm getting, please check. I'll solve this one first. So I have 10x minus 35 minus 6x minus 9 less than equal to 0. So I get here 4x minus 44 less than equal to 0. It means 4x is less than equal to 44. It means x is less than equal to 11, right? Moving 44 on this side and then dividing by 4. Okay, great. First one is done. What next, sir? I'm going to use this one now. What I have, 2x plus 19 is less than 6x plus 47. Okay, let's move 2x over there and 47 on this side. I get 19 minus 47 less than equal to 6x minus 2x. Please check. So I have over here 17 minus 9 is 8. Okay, and I have 3 minus 1 is 2. So minus 28 is less than equal to 4x. It means 4x is greater than equal to minus 28. It means x is greater than equal to minus 7. Okay, so plot on the number line. What I have, minus 7 over here, and on this side I have what, 11, right? Put plus minus, sorry, I don't have that case over here. I can write it like that also, but we don't have the case over here. Okay, they don't have the wavy curve form. Okay, we'll take that questions later. Right now we'll close this over here. What we have here minus 7 to 11, right? So we are looking for this only, greater than minus 7 less than 11. This is your answer. Closed and the line joining between all the points on the line joining between them. Answer is going to be x belongs to, please check, minus 7 closed to 11 closed. Or I can write this like this, x is less than 11 or greater than minus 7. Option is A. Option is A. Okay, so I hope this is clear and simple. This completes the chapter, linear inequalities. Okay, so yes, I have taken only these few things, but what is important for your syllabus, I have covered everything. Okay, so again, if you have more questions to practice, you'll get from my side again. Right now I'll end the session over here itself.